Hi, this is Divya, Assistant Professor, Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about the basic principles of tomography. In the previous videos, we have saw about the history, the need for tomography and the introduction. Here we are going to see about the basic principle of tomography. What is the basic principle? If there is a synchronized movement between either of two among the three, that is the patient, X-ray tube or the image receptor, okay, then there is a blurring of image causes. Okay, if there is a synchronized movement, okay, if there is a synchronized movement between either of the two among the three, we have three elements, right? Patient, image receptor and an X-ray tube. X-ray tube is a sender, receiver and an patient. We have three elements, right? If we have a synchronization between any two of these three, we'll have an image blurring occurs. This is the main principle of tomography. Okay, if we have any synchronization, any two products, any two elements, which is either the receptor and then patient, or a patient and then X-ray tube, whatever may be, in these three any two gets synchronized, okay, then there is a blurring of image occurs. While movement, only one thing, A is constant, that is a fulcrum 3 point of the tomographic equipment, and the plane who possesses its point is well demonstrated. Okay, we have a point called fulcrum or the plane of interest. Okay, it is called as fulcrum point or a plane of interest where the 2 points get intersect each other. That point is said to be A, or a fulcrum point or a plane of interest. Okay, once this point is intersected properly, the image will be of a very good image. We will not have any blurring in it. Okay, it also results blurring of image of that structure while lies above and below of that plane. We have a certain point called fulcrum or a point A or a plane of intersect. If that plane has, we have a particular point over there, if that plane crosses either above that point or below that point, will have an blurring in the image. Will not able to find any proper images. In the image we can find that we have T1, T2, okay, film 1 and film 2. We can find a fulcrum point, right, theta, the plane of interest. That point will be of the image or the X-ray line that should pass that fulcrum point. If it is not so, the image will not be of a proper image. It will have a very blurred images, right? Another image you have a three intersect lines, right, K, L and M. Okay, K, L and M. T1 is a transmitter and T2 is a receiver. Okay, T1 will transmit rays to the patient, and from patient the T2 will connect, that is a detector that will collect. These 3 points should be intersecting. These three, not these three, plane 1, that is a receiver and a transmitter should intersect. If it is so, the image will be in a proper size or a proper position, or it will be in of a clear image. Okay. Next, now we'll have a continuation of the previous one. Now the synchronous movement can be achieved by any of the following methods. We have 4 types of methods. The synchronization, right, that the point which is to be intersect, that can be done by these. The film remains stationary while the X-ray tube and the patient moves. CT is all about moving. The patient will be moving, or the X-ray detector and sender will be rotating, right? Here, while the film that is patient, where the patient is found, film remains stationary while the X-ray tube and a patient moves. Next one is the X-ray tube remains stationary while the film and the patient moves. Third one is the patient remains stationary while the X-ray tube and the film moves. These 3 will be alternatively moving. If it is happened, okay, the process is done very perfectly, or else it will not have any proper images in it. This is the most accepted technique used. Okay, this process is this process to be done perfectly. If there is any flaws in it, the images will be of a blurred one. We cannot get any clear images. Thank you.